Serbia University School of Computing. Thank you. I have assistants here. Thank you. Maybe to start with a question, which I love to ask my students. Do you know here or online which image is on this presentation? Do you know the background? Maybe? No, it looks like, yeah.
DNA?
It's some structure. No, not really. It's not natural. It's some structure. Maybe you can say I. You see, when you zoom it, each part of it, if you zoom it, it represents the whole image inside. Do you know self-similarity characteristics is for fractals? Have you heard of fractals? Fractals are my main theme. It was my PhD applying multifractals on cancer detection or classification in searching for primary cancer in the state of metastatic bone. So I will represent some intelligent systems tools for cancer detection and prediction of efficiency of chemotherapy, special kind of chemotherapy. Is it here? Okay. Send that. Okay. It's not scared. It's not sharing on Zoom. Is it shared? Yeah. I used to go to work 19 years in Institute Mihajlo Pupin, University of Belgrade, and teaching parallel of School of Computing, another university. From six years now, I'm teaching and research with my students, PhD students, master students. Here are some my collaboration with the medical faculty. I am PhD of electrical engineering, but I have collaboration with medical doctors usually. So why fractals and multifractals, and some benefits of applying multifractals are that there are no degradation of original images. There are no furlough filtering, and that is way of regulation analyzing. And when I was doing my PhD a long time ago, actually I founded many or several in those days, but nowadays many science papers with the application of fractals and multifractals, because the fractals with, I think, that main characteristics of self-similarity, it can explain carcinogenesis. The first application of fractals, or some first or primary application, it was a theory of chaos, explaining how, universe became like this. But that explanation from theory of chaos, it can be presented on the application on explaining of carcinogenesis. It is not so chaotic that multiplying of cells. My PhD was from metastatic bone metastatic to find those three groups: primary lung carcinoma, primary breast carcinoma, and primary renal cells carcinoma. I didn't know until then that there is something that medical doctors can do with metastatic patients, because my father died a long time ago from metastatic, and I thought it's, end of the story. So there is some hope, and for those patients, if they find that primary cancer, they cannot apply chemotherapy. Have trained on the whole. I opened here. Of course, normally they cannot apply any kind of therapy on the whole body, when metastatic, because metastatic usually get to bones or brain or the whole body, fortunately. So it is very crucial, important to find that starting point, primary cancer. It's really crucial. Okay, I have applied for PhD program FRACLAC from Australia University in collaboration with that professor there. And okay, there is another in Paris university. There is an institute in Rio. There is institute in Rio, if you have heard, in Paris, only for fractal analysis, if you have heard. But for my magisterium, that is kind of master now degree, I have done comparison of FRACLAC and FRACLAB from Rio in Paris, and I found it FRACLAC much better. You can apply it on big data images, big base data images. Okay, and for statistics, you need statistics, of course, after any kind of machine learning. So I applied in that year data registration, very good statistical data analysis program. And before that, I had applied SPSS, but data registration, I think it's much better. SPSS is much natural, maybe for medical doctors, psychology. Okay, and I had my general hypothesis was that those 6 parameters used from fractals, actually from multifractals, that's why it's named multi-parameters, that those 6 parameters will be in correlation with those 3 primary cancer groups. Okay, and after applying it and after applying statistical analysis, I had 1050 tissue images. It's really interesting that medical doctors, they take biopsies from bone tissue, and they are searching for totally different primary cancer, from lung, breast, and renal cells. So it was really fantastic for me. It's really hard to distinguish difference. I needed to learn that differences. So, for example, this was actually example of metastatic carcinoma of renal cells. Everything is from bone taken, but it was primary started in renal. This was primary in breast, and third one example started in lungs. So you can see it's really similar. It's hard to distinguish. It's not too hard to distinguish when it's health tissue, because it's normally cells not like this, Okay, so it was FRACLAC. I needed to put it first in binary, and after applying statistical data registration program, accuracy was really good according to 3 groups, over 78% for lung carcinoma, and other parameters for statistics for breasts over 73, and for renal cells over 76. Okay, some recommendation according to this research is to apply on other organs, other types of metastatics, or not just metastatics, maybe just to distinguish between health and benign and malignant tissue. I did that for a master's degree for colon. It's not really easy, even that, to do it. And next, after this PhD, which was with this project, it got big awards on technical and medical fair and competitions. It was kind of some really media stuff in that time, 10 years, 12 years ago. So after that, I got offered to do this project, which was really, really, for me, it's the best results. And so we got images. I didn't have to go to hospital every day to make images, which was, by the way, the worst part of, the longest and the worst part, because every medical doctor thought that he will or she will lose job because of me, but I need just to help them. So it was applying multifactorial analysis on tumor microscopic images, but in prediction of breast cancer chemotherapy response, but specific chemotherapy. And it was in collaboration with our Oncology Institute in Belgrade and my institute in that time and the whole medical faculty. And there were also my colleagues. Okay, we again had 3 groups with partial pathological response, complete and progressive stable disease. I don't know, do you know, but state of the art is that there is no some, computer or AI, digital, any kind of method distinguishing is that specific patient for that therapy. They just tell them some statistical numbers, but unfortunately, as I know, and I think I know, that there is no such thing. So that's why these results are very important, because accuracy after applying and multifactors and statistical program were very, very good. Over 91% for partial response, over 98% for pathological complete response, and over also 82%. So you can say in this study were all women, but breast cancer, it can be at men also, but very much less. So you can tell specific that women or patient with really good accuracy that specific chemotherapy will have this response if they apply it to her, if they took biopsies and all this, apply this software. I gave this software to clinic in Belgrade, but unfortunately I don't know why, but they are not using. So maybe here on these conferences we can have some option to collaborate from whole world to get all types of images to make better those analysis. So it was very sad after that those awards, I got emails and from patients with the metastatics. They are asking for help but this kind of chemotherapy, it is one of several. So we need to apply this research on other types of therapy, on other types of cancer, not only for breast cancer. That's why my colleague from Institute Lazar Bebakov and my two best students in that time, we made medical research platform. I think it's now on the platform India Go, I think. Several days ago, I got that idea. I think Lazar put it, I hope. So you can show it, you can see it. I will send you that link. But the main goal is to get as many as more images in order to make better those analyses. Because after multifractals, we applied CNN neural networks in order to make it much faster and much more accuracy higher. So we tried that in Belgrade, in Serbia, but I don't know. We were in final of some competition for startups. I was in final in China 2017 for innovation, but never, first place. So there is no, for now, no other results, but we hope maybe from Indian Go, from such conference, or I don't know, ChatGPT or Google or something, we will get much more results and application. So we offered to our main private clinics, groups, to do all of those machine learning statistics in exchange for in real time images for any kind, even ultrasound images we would like to analyze. Because, for example, for liver, there are, I think, 5 types of cirrhosis, and they must take biopsies for that. And if they make mistake, it can be really invasive, and they make errors, of course, when they take biopsies. So we offer that. These are some functions of that platform data to make some universal database on internet, because I don't know. I have some answers why there are no such database of microscopic images specific. We can offer data analysis. We have an educational platform, and we can share knowledge between doctors, because it is not only that patients need another opinion and doctors need another opinion, but all of them want to be anonymous, everybody needs Dr. House or something, something like that. So database will have or already has those characteristics. And of course, because everybody asked me for data privacy, I don't know any name of any patients. We have some just unique number. But on this way, we can follow that health history, on the same place. Because in Belgrade, in Serbia, there are kind of, fortunately, like epidemic of cancer. It used to be, I think, also now. And people, in panic, they are going to one clinics, to another clinics, private clinics, and lots of money and lots of time, and there are no such health history on one place. And they don't know that, many people don't know that every person, we have some limit, maximum of radiation in the whole life, when you teeth got scan or lungs in COVID or whatever. It is cumulative, and we have some maximum. After that, it can be, unfortunately, even in cancer. So these are for platform. As I teach my students on computer university, especially on medical faculty, they would have benefits of this platform. Sharing data, as I said. We have also cooperation with Institute for Neurology, with President of Serbian Academic Academy of Science, because my idea, I used to teach sometime in Australia, and there were kind of like question about multiple sclerosis reason, how it is spreading algorithms, and I offered explanation with, again, fractals. Like cancer is multiplicating cells in multiple sclerosis, like on like on this wire. They are losing, on those neural networks, ions. They are losing cells. I think it's like a mirror, some algorithm. I think. And that we can apply in fractals and multifractals and CNN, especially, in targeting. So this is my last favorite fractals, but more to say that I hope and I really truly believe that this all can be applied to neural diseases and many other diseases. It's not only for cancer. I was for cancer personally attached, so for detection and curing. So that's it for me. Thank you. Any questions?
I had one question. Does the resolution of the training data have a big effect? I don't know that space really at all. I would presume that there would have to be like a lot more noise added in order to have a good effect. But I'm curious on, as resolution gets better and better, what that might be doing.
Resolution of these softwares.
Yeah.
Because if you find it on the early stage, you can apply several, types of therapies. Which company is best in that early stage detection? Google. There is a G-Ray, something like that, like daughter company. So when you have much more information, you can detect it in early stage. Metastatic is, final stage, unfortunately, but then for that stage, even there is hope if you find it primary stage. But especially if you find some cancer in early stage, you can cure it really successfully. Yes. And beside this, nanobots is really good. I have collaboration with the Houston Professor Mauro Ferrari. He is our abroad, academic, but they are applying nanobots you make for, personal medicine. That is future. I think it's present in USA, as I have heard. I don't know. Maybe it's not really allowed still from FDA, but he said that they cured a final stage of pancreatic cancer, which is, there is no cure for that, especially because they made some combination of therapy, but special for that person, and they took it only to cancer, because the new effects of chemo, especially, is that it is targeting, it kills every cell and have cells. Many cancer patients, they got cured, but after that, unfortunately, they die from regular flu, because their immunity is zero. So we need some targeting. In Sydney, they are doing in the same time and screening and the radiation. In that way, they are not making errors in radiation.
I also have a question. In this kind of fractal analysis, can it be applied to the raw data, or something reprocessing of images? Or
okay, I don't know if you have heard, but the question was for, is it raw data? Of course, it's not. But if when I was doing my PhD, I made it all the same, you know. But if you find like Kegel, you know, competitions, you need to maybe normalize. It needs to be all uniform, you know. Daikon, if you have heard it, is for Scania, you know it. It cannot be, I think it's too much. I think it needs to decrease resolution. So it needs to some changes. If you have meant on that or putting on binary.
For example, some moving or, applying some kind of,
Oh, there,
this kind of
I haven't
cropping,
played.
you know,
Cropping, yes, maybe decreasing resolution
Okay.
for if we are talking about Daikon, yes,
Oh,
yes.
fine.
That's why I believe more in when I make those images. If you take it for some clinics that you know, because we had on master degree some they went on that Kegel competition, and our radiologist he examined those images and he said it's not true. I don't know who to believe, you know, to our radiology, but for sure, if you have like that database for some competitions, they are from different clinics, and they are not from the same scans, or so it can be problem. Yeah, yeah.
Yeah.
But nowadays, after COVID, I don't have any. I don't know, some collaboration really in live. So my students they took all from net. There are some good links now. We hope they are on the same conditions to image it. Okay.
Cool. Thank you.
Thank you. So